The question says, write the dimensions of the following quantities. We know that force, let's do it here. You know that force, I'll be very fast because I've made video on this before. Force is equals to ma. So F is equals to m. Acceleration is Lt raised to the power minus 2. And we know that dimension is simply the measurement of physical quantities using mass, length, and time. This is the dimension of force. B, viscosity. I told you that viscosity is simply the ratio of force to the product of area, to the area and the velocity gradient. And I told you that anything gradient is that thing over length. So this is the same thing as saying mlt minus 2 all over L square. Then velocity gradient is the same thing as saying Lt minus 1, that is velocity for L. This and this will cancel, so that I'm left with L here, 1 will remain. L here, this will get out. So this I'm left with L that is raised to power 1. So I'm having mt minus 2 all over Lt minus 1. And applying division law, I'll now have that this is the same thing as saying ml coming up minus 1 t minus 2 plus 1. That is minus. So I have ml minus 1 t minus 1. This is viscosity. Young modulus. Young modulus is simply stress over strain. And we know that strain is the same thing as stress is the same thing as pressure, force over area. And strain is the same thing as saying extension over original length, L over L. Anything by itself is 1. So I'm left with F over area, which is the same thing as saying ml t minus 2 all over L square. 1 go here, cancel this one, so I have just 1. So this is the same thing as saying m, then that L coming up minus 1, then t minus 2. So this is Young modulus. Impulse is simply gotten when you do that second law of when you use momentum, change in momentum, and you will get that this is equals to product of force and time. That is seconds. So this is going to give me see how it's done. I know that momentum is equals to mass and change in velocity. And change in velocity is the same thing. Change in velocity is the same thing as saying change in velocity over t. So I now have that momentum is equals to mv over t. And if you look at everything here, it's looking as if it's m and a, which is that force. So that means that this is the same thing as saying force is equals to mv over t. So when you cross multiply, you have that ft is equals to m change in velocity. So this f and t here is what we call impulse. Impulse is equals to force times t. So this is mlt minus 2 times t, and which is the same thing as saying mlt minus 2 plus 1 using product rule of indices. So this is mlt minus 1. So this is the dimension of impulse. So let's move to hope I'm not too fast. Can no go make mistake. Alright, let's move to the second part. It says Using dimensional analysis, show that the following equations are correct. What it means is that you have to show that a v is equals to u plus at. When they tell you to show that an equation is correct, anything you have when you're doing dimension, I told you the first law of dimensional analysis is to note that everything given is product of the variables. The dependent is equal to the product of the variables raised to unknown power. And when you introduce a quality sign, it becomes key. Then when the second law is that anything that you see on the left hand side has the same dimension with the right hand side. So I will say v is equals to u and v is also equals to at. Now notice that v equals to u, this is velocity, which means this is final velocity and initial velocity. It's the same thing as saying lt minus 1. Velocity is displacement over time, is equals to lt minus 1. So it's the same thing. Now let's check for the second one if it's correct. This is the same thing as saying v lt minus 1 and acceleration is lt minus 2. Then it has times time beside it. It has time beside it. And when you do it, you see that this is lt minus 1 is equals to lt minus 2. Using product rule, there's an invisible one here, plus 1. You add the powers. So this is the same thing as saying lt minus 1 is equals to lt minus 1. Hence, it's correct. So it's correct. So what you have, whenever you see this kind of equation, what you do is you split it in such a way that you have v equals to the first part, v equals to the second part. So you can see that v is equals to 80, v is equals to u, because it gives you dimensions that are the same on the right and the left hand side. Now let's go to the second part, which is b. They gave me that b, I have b to be t equals to 2 pi root L over G. So let's check if it's correct. This will be the same thing as saying t is equals to 2 pi, and we know that anything root according to indices fractional power law, this is L over G all raised to power half. This 2 pi, I have no business with it. What I'm looking at is the quantity. So this is the same thing as saying t equals to L raised to power half all over G equals to raised to power half. And we know that this is now t is equals to, we are trying to check something. This is now the same thing as saying t equals to g acceleration due to gravity is the same thing as saying lt minus 2 raised to power half all over L raised to power half. And this is now the same thing as saying applying distributive power law. This is now the same thing as saying L raised to power half all over L raised to power half t raised to power minus 2. Minus 2 times half over 2. You can see that 2 here, 2 here. I'm left with L raised to power half all over L raised to power half t raised to power minus 1, because anything divided by itself is 1, then it's carrying minus. So notice that this is L raised to power half, L raised to power, these two can cancel. So that I'm left with 1 over t raised to power minus 1. And notice that anything raised to power 1 means negative indices. So if this thing is coming up, when this minus is coming up, it will now be, applying division law, it will now be t raised to power minus 1, which changes to plus. And notice that anything standing on this one is equals to 1. So this means that t on the left hand side is equals to t on the right hand side. Hence proved. It is correct. It is correct. So dimension is simply saying that anything you have on the left hand side should be the same with what you have on the right hand side. So hence it is correct. Hence correct. So let's try to look at number 3 question. Number 3 and the last one. They said given that a bulb of mass is attached to an inelastic thread of length L and allowed to undergo simple harmonic motion for a period t in a gravitational field of acceleration due to gravity. Using dimensional analysis, confirm the exact relationship between period, length and time. Period, length and acceleration. So this is the same thing as saying anytime you are giving this kind of thing and they are asking you to find the relationship between them, all you simply need to do is to make the dependent. Everything you see in life is a function of time. So every activity is a function of time, which means that in that case they are time dependent. So the key thing there is time. So I will make T subject of the formula. And I told you that anything that is dependent, anything that is the subject formula, is equal to the product of all the variables given. So I have M, L, G raised to power of unknown x, y, and z. This is the first rule of dimension analysis. So I said anytime we introduce a quality sign, we introduce a proportionality constant. So this is what I have. So that I now have T is equals to, and this is the dimensional constant, which is 1. So 1 times everything here is Tm. So let's say I have m raised to power x, l raised to power y, and g is the same thing as saying lt minus 2 raised to power z. So when you apply distributive power law, you have l raised to power z, t raised to power minus 2z, l raised to power y, m raised to power x equals to t. And remember that the second rule of dimensional analysis states that what you have on the left hand side should be equal to what you have on the right hand side. Left hand side, I only have t. There is no m, there is no l, but I know that anything raised to power 0 is 1. And when I come and do 1 times 1 times t, I still have t. So let me apply it. M raised to power 0 is 1. L raised to power 0 is 1. So t. And this is raised to power 1, because anything raised to 1 is nothing. So m x l raised to power y, l raised to power z, t raised to power minus 2z. And notice that I can now say on the right hand side, let me apply multiplication law of indices. I have m l raised to power y plus z, then t raised to power minus 2z. Notice that at this junction I can now apply the second rule, the third rule, which is equate the basis. So that is the ninth rule of indices, equating basis, that when the bases are the same, the powers are equal. So for m, I will now have that m on the left hand side is having power of 0, and on the right hand side, this is the same thing as saying mx, is having x, so equals to x. Therefore x is equals to 0. So for L, on the left hand side, L is 0, and on the right hand side is equals to y plus z. I leave it at that. Now for t, on the left hand side is 1, is equals to, on the right hand side is minus 2z. So I know that since this is z, I can say divide both sides by the coefficient of z, which is minus 2. I divide, so that I have that z is equals to minus half. Now remember that for L it is carrying z, so let's come back here and now do that. This is the same thing as saying 0 is equals to y plus minus half. And notice that this will be 0 equals to y minus half. If you want to make subject of y subject of the formula, this minus half will cross a equality sign, so that I will now have that y is equals to half. So which means that y is equals to half. Okay, which means that x is equals to 0, y is equals to half, and z is equals to minus half. Then applying what we have now to the relationship, we can now see that this will easily be the same thing as having, remember that we have the relationship to be t equals to k m x l y g raised to power z. So this will easily be t equals to k m raised to power 0, l raised to power half, and g raised to power minus half. And t will now be equals to k times 1. Then l raised to power half is the same thing as saying root l. Then g raised to power minus half is the same thing as anything having minus 1 as minus as its power. has numerator of 1 all over g, then raised to the positive power of that power. So t is equals to k root l all over root g. Applying fractional power law to this, and this is the same thing as saying k root l all over g. That is your thing. And this thing is the same formula that we make use of when we are doing uh, uh, simple harmonic motion. Simple harmonic motion, anytime you're doing simple harmonic motion and you're finding the period, this is the same rule we use. And you know that this is also equals to 2 pi root l all over g. We don't, this constant here, we don't put the 2 pi when we are doing dimension, because it has no use, but you need to note it. So this is your final answer. Thank you very much. I'm being very fast because we've done this before.